understanding the benefit of the percentage and how it standardizes the fraction. Decimal is just a percentage in disguise, or the other way around, I guess. Let's see what this is. Estimate percents of numbers. It might be a little fast, but let's see. Let's see what that's all about. Let's see what that's all about. Which is the most accurate way to estimate 25% of 34? Well, that's a loaded question. When it comes to estimation, I like to tell people, well, you can technically not be wrong if you say estimate this, because I don't know how accurate you want the estimation to be. And if you want to be all the way perfectly accurate, then it's not an estimation anymore. So there's a very large range of what estimation could really mean, and it can be quite flexible. The most accurate is the actual calculation. I wouldn't call this estimation at all. If I'm doing the calculation, then I'm not estimating. Estimating means looking for something that's close but easy to find. This is just actually calculating it. But it does depend on the options I have here. So let's just look at this exactly. They want to convert this to a fraction calculation. Well, 25% is 25 over 100. Now we've seen before that a fraction of a quantity, that's going to be multiplication. So I'll just go over here. So I'm looking at 25 over 100 times 34. Now I can simplify this fraction, not always necessarily, but in this case I can. I can divide, I can notice that 100 is 4 times 25. Let's write that down maybe. So I have 1 times 25 at the top, 4 times 25 at the bottom. I have that common factor. So this is all the same as 1 over 4 times 34. So this is going to be exact. If I want to calculate that, I could, in fraction language, calculate 1 over 4 times 34. Now what do they want here? Which one is the closest to this? Honestly, it's a silly question because the exact answer is not that much more complicated than any of these, really. So they're making something more out of something that shouldn't be this complicated. Now I have to check every one of these. Why can't I just calculate this? That seems like way more work. But okay. So I see the 1/4 here is the same as the fraction that I'm applying to my quantity, but the quantity is not the same. So here, 1/4 of 36, that's the same as 36 over 4, which is the same as division, so that's 9. But I'm taking 1/4 of less, so my answer is going to be a little under 9. But it's going to be close, so this is going to be a little under 9, because taking 36 does make an easier calculation. I can do it in my head. Not that this is super hard, but it is technically easier. Whereas the others here, I'm changing the 36 and I'm significantly changing the fraction as well. This is 36 over 2, which is 36 divided by 2, which is 18. That's way off. I'm just a little under. It's a minor change from 36 to 34. So yes, they're certainly making this a much bigger question than it needs to be, but here we are. This one, let's do this one first. 1/3 times 36. So now I'm changing the fraction from 1/4 to 1/3, which is significant. and I'm changing the 34 to a 36, which is hard to know how significant that is in general. But 36 over 3 is a simple division. 36 divided by 3 is 12. And I know I'm a little under 9, so far this one is the closer choice. Overkill for sure. I could have, in all this time, I could have just done this. Let's see if we could squeeze it in here and say this is 34 over 4, which is just a division. Even if you want to do a whole thing, not that this requires a long division, because 4 doesn't even go into 3. So I'm going to have to look at multiples of 4. That gets me close to 34, which will be 8. 8 times 4 is 32. Take that away. I have 2 left. So whether you write it like this, remainder 2, whether you write 8 and 2 over 4, simplify that to 8.5, it wasn't really much more effort than having to look at all, modifying it to something that doesn't have a remainder, then compare it to other ways of modifying it. It all seems quite silly, to be honest. Now, in general, if I have a messy decimal number here instead of the 34, there could be benefits to estimating. This one seems to make a much bigger question of something that I could have just done accurately and precisely. But 2/3 is a significant change from 1/4 is a little fraction. 2/3 takes a big, much bigger portion of a slightly bigger amount. Yeah, I'm going to leave that to you to calculate. That's not even going to be close to 9. This is going to be my closest option out of the ones they gave me, because they wanted to make this question a hassle. I could have just calculated this in all this time 3 times already, but here we are. That was interesting. That was very interesting.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
Which is the most accurate way to estimate 32% of 85? Okay, this one, I didn't mean to click on that. How do I unclick it? I have to click on something. I don't know. Let's click on the first one. I accidentally click on something. This one can justify some little estimations for sure, because 32%, it's not like 25, which simplifies to a nice fraction. 32% is slightly more annoying. 32 over 100 times 85. Yes, okay, so that is more of a hassle for sure. So what I can do with estimation, and again, there is no specific rule here. That's what makes estimation both nice and annoying, that I can kind of do whatever I want, because there's no, just this question, estimating this, well, how close do we want to be? The closer I want to be, the more of a hassle the calculation is going to be. If I go to convenient numbers, then it's going to be super easy, but my estimation could be way off. And anything in between is also kind of valid. Now, they gave me some options here. So I want to see what is being done in each of these options. Well, first of all, I look at this and I see, okay, it's going to be hard to know if I change both of these. It's going to be hard to know how my answer is affected and compared to the actual precise answer. But I do notice here that 32 out of 100 is very close to, let's do it like this. It's very close to 33.3 repeating over 100, which is a third of 100. So the smallest change of this percentage to a familiar simple fraction will be to a third. I have changed it, and I don't know how much of an effect that will have on my final answer. I went a little higher, so I went up a little bit on this one. Instead of 32%, I'm making it a little over 33%. So my estimation this way is going to give me an answer that's a little bit more than 85. How much more? I don't really know precisely, without some effort, of course. The whole point is to make it something I can do in my head. Now, unfortunately, 85 is not a multiple of 3 that I can just do a division, although that division is also not very difficult. So let's just do it exactly and see. Maybe we need to do this. I don't know. That's for you to decide. 3 goes into 8 2 times, using 6, which is really 60, leaving 25. 3 goes into 25 8 times, using 24, and I have a little remainder left. So this is 28 and a third, which you can write in a variety of ways. So I'm a little over by, let's say, almost 1, a little less. So I know I'm close to my number because I only went up to 33%, which is roughly a percent, which is a hundredth. A hundredth of this is 0.8, so I'm probably like 0.9-ish off. So I'm a little high. So my guess, again, rough, my mental calculations are not anything amazing. My guess is that I'm probably around the 27.5 is closer to accurate. That's not exactly the answer, but it's close. So now they want to make it. So the nice thing of estimation is they didn't tell me how close I should be in general. So is that good enough? Well, sure. That's the nice thing about estimation. I could be far off. I could have been much more aggressive as well. So now we have to annoyingly see which of these gets me close to my current guess, which I know is pretty close. It's in the 27s. Some of these are going to be much, much more aggressively estimating than we want to be. So let's look at the half of 87. So they went up to 87, but the fraction also went up because I was close to a third. Now it went to 50% of 87. But that is also an easy-ish calculation. They still have it an odd number, which is a little strange. But we can calculate this one easy enough. Half of 87, 87 divided by 2, that's going to be 43.5. Do as much detail as you need to, of course. A third of 84, so they did go to the obvious third, which is what we did, but they lowered the 85 to have a multiple of 3, which is fair. Now the division wasn't super hard. They went to 84 instead of 85, so they wouldn't get a remainder, so they would just get 28, which is arguably a little bit easier, sure. It's just a little bit hard to know if I change both numbers. I change the percentage slightly and I change my number slightly. Now it gets increasingly confusing to know whether I'm above or below in my estimation compared to the exact answer that I'm trying to estimate. I always want to try and just estimate one, or not estimate, and just alter one of the numbers involved. If I change both, especially in opposite directions, one went down, one went up, it's very tricky to know what effect that has on my estimation. Am I above the answer? Am I below the answer? That is very hard to know in general. That's why my first strategy was this. If they just tell me estimate, this is how I would do it. I would try and not change both, because then I know I know here that because I didn't change the 85, I just changed that by pretty much a percentage point, which is 100th, and I can divide this by 100th very easily to get 0.85. It was close. I changed it by a little bit more. I know that I'm above by a little under 1. But if I change both, that's pretty tricky in general. What would they do for this one? So if I did this, that's my point. If I did this, I get 28. Yes, the calculation is mentally easy, but I don't know, is the answer a little more than 28? Is it a little less than 28? I'm really not sure every time. Sometimes it's going to be more. Sometimes it's going to be less. It depends on the changes that I made and how small they were and how they relate to each other. And that can be tricky. But it's certainly a better estimation than the previous one. So at least let's update to this one. That's our current best choice and probably the best one. But let's check the others. This is quite a question. Much more than I expected. Wow. But there's also so many good things here, practically good things, that out there in the world, percentages are everywhere. And if you can get a sense for percentages and how they compare to each other and how they're and familiar percentages and how to estimate reasonably, you really have a life skill that is beyond any specific job you're training for. Life skills like this are really good. Anyway, 1/3 times 87. So they changed the percentage in the same way, which was reasonable. And then instead of going down to the closest multiple of 3, they went up to the next multiple of 3. So this would then, based on what we've seen here, be 29, which is reasonable. If I'm going to change them, if I change them both higher, I increase them both, now I'm taking a larger percentage of a larger quantity. So I know that I'm overshooting in my estimation. I might not know exactly by how much, but at least I know which side of the actual answer I'm on, which is arguably a little better than changing in both directions. It depends on how aggressive the change is. There is really no set rule for estimation. So I know I'm over, at least. I know where I'm at. Whereas with this 28, if I just did this, I'm not sure if I'm above or below, because I wouldn't have done this on the right? Now we didn't do a change in both, so we are safer in knowing and being close and knowing which side we're at. Let's check the last one here. This was an aggressive. If I change the fraction to aggressively, my number could be wildly different from the accurate one, from the exact answer. I have to be careful with that. They changed it to a half again. The 84 is I guess a multiple of 2 that's close. 86 would have been nice here, but they didn't do that. So it's an easy calculation to mentally do to a 42, but you can see it's way off, much further than these middle two. So estimation can be really tricky, but there's a crossover that if I want to be very accurate, I might as well just do it. Take my time, do it right, because this is 0.32 times 85, which means I just need to do 32 times 85, which is not the worst thing ever. It's going to be slower, but at least I would know. Once I start moving things around, now I don't know if I'm up or down. There comes a balance between efficiency and at least knowing what the actual answer is. It's a tricky balance. However, I think I'll go with the second one. If I just did these and I didn't do these things on the right, that'd be really tricky. That'd be really tricky to choose in general between these two. Yeah. You could argue that, well, the change to 84 was smaller, and the percentage that I changed to in a third is the same, so this one should be closer, which is correct, yes. Sometimes I change this one too, and it's not obvious, and I don't think it's fair early on to expect it of yourself to have the number sense to be that clear on distinguishing between these. It's very tricky, which is why I would try and change just one in my estimation when possible. Let's see. It's right, yes. So these can get quite annoying. However, with the effort that we put in here, that's also a very good development opportunity, and my number sense has increased a lot just by doing these couple of questions. It's been really good. Is it a hassle? Yes, but you really get better by just spending time digging in and thinking about these things. It's very, very good. I'm going to leave this one for you. You can let me know if you want to check your answer. But there's a lot of good things here for sure. Very interesting. What turned out to be an annoying estimation question actually has a lot of benefits. So I don't mind to admit that I was underestimating that question. Underestimating the question. A little bit, yes. That was really good.